the sun's magnetic fields are very complex. The sun is just not a big bright ball of glowing gas. The sun is also a big ball of magnetic fields. But they tend to concentrate into very small, very strong magnetic field regions. And you see several of these here. The strong magnetic fields are where the surface of the sun is dark in this very detailed image. The magnetic fields hold a lot of energy. And when the magnetic fields become twisted and tangled, they want to release this energy. So all this energy gets transferred to the atmosphere of the sun and causes it to glow, and that's the flare itself. So here's a movie of a solar flare, one of my favorite movies, showing you all the complexity in a flare, all the different regions that light up. And this is what we try to understand. So in a solar flare, about 100 million atomic bombs worth of energy is released into these tiny brightenings. So we don't have such dramatic movies of flares on other stars. We can't see such detail. But other stars produce much more energetic flares. So here's an image of a star field. You can see some of the stars here as black points. So it's a reverse color scaling. The brighter stars are blacker here. The image on the left, there are no flares occurring, but on the image on the right, a star produced an incredible flare. It's the star that's indicated with an arrow in this image, and during this flare, the star increased in brightness by 100 times. The sun does not do that during flares. So this was a very dramatic flare in another star that we observed. So what we can do with flares on other stars is we can obtain spectra. We can measure the amount of blue light to the amount of red light. And with this, we can measure how the temperature changes during the flare. So here's a spectrum of a famous flare on another star. This other star is a red dwarf star. We call it the mega flare because it was so huge and produced so much energy. So what we show here is the flare spectrum. And with this spectrum, we can measure the temperature of the flare. So we've measured the temperature of this flare to be about 10,000 degrees. This is really dramatic because normally the star is about 3,000 degrees. And it takes a lot of energy to cause the star to go from 3,000 to 10,000 degrees. We have a classification for flare size in the sun, and the largest flares are called X-class flares. This flare, the mega flare, would have been an X 1 million flare. So 1 million times more powerful than the largest flares in the sun.